Welcome to the Evo India podcast. Today, we are talking about electric mobility, especially in the Indian perspective. In fact, we structured this like everything you wanted to know about electric vehicles but did not know whom to ask. And today, we have the perfect person whom to ask everything we want to know about vehicles in India, e-vehicles in India. Anand Kulkarni, Chief Product Officer at Tata Passenger Electric Mobility. Anand, welcome to the show.
Thank you, Shirish. Pleasure to be here today.
So, we've always wanted to do this podcast, talk about EVs, and there is a lot of talk around EVs, right? From the government side, from customers, from all across. There's also pros and there are cons. And Tata Motors is unashamedly the leader in this electric vehicle space. Nobody is done so much for electric mobility in India as Tata Motors, and nobody has as much as advanced plans as you guys have. So, let's start with where did Tata Motors start this whole electric mobility journey with?
Okay. So, if you see, Shirish, this dates back to quite a few years now, and you would also have heard about some projects that we did as a demonstrator project, or some very specific projects were undertaken. And I am going to go back 15 years, 16 years in time. So, Tata Motors European Tech Center is situated out of the Coventry in the UK. And the Coventry and Birmingham governments had at that time come out with a scheme called Cabled, which was, I think, Coventry and Birmingham Light Emission Vehicle Demonstrator.
Okay.
And in that, manufacturers were encouraged to come out with demonstrations of electric vehicles, which could then be handed over to the average public to create awareness, to get more data, to understand how electrification would work, and so on and so forth. So Tata Motors participated in that. The TMETC bunch of engineers were also there. And together, we created the first Tata Motors electric vehicle, so to say. It was on so we needed a platform to make it happen. And it was done on the Indica Vista. So the Vista was at that time called the Indica Vista. So this was that vehicle. And we created a demonstrator. I think we created about 25 odd vehicles. They were given to the average people on the streets, and people use these vehicles. We, of course, collected a lot of information. So it put to test some of our early integration skills. It brought to our attention the kind of usage patterns that there might exist, and therefore what kind of strategies would work and what kind of strategies would not be so ideal. And that, I think, was the first initial start. But then back in those days, the economics of an electric vehicle was still yet to come to a maturity.
Economics in terms of what? The battery
battery
costs?
prices were significantly higher.
Okay.
And also battery, I mean, look at it this way. In the last 10 years, 15 years, there's been a lot of improvements that have happened in battery technology. Prices have come down is one thing, but also energy densities have grown. It has improved significantly. So all of this has now come to a sweet spot where you can have a reasonably good range on a car. And therefore, demonstrations of these sorts, far ahead of their times, help in being able to understand what the technology is and how the optimizations will work. And that's what the Cable program did for us, I think, which of course then later on helped us during the making of the Nexon EV.
Do you think this is the future?
Well, I think it is the future. There will always be questions about whether it is an immediate future or whether it is a slightly later future. But I think this is the future, because this is the only way that you can go to a more sustainable mobility. And it's proven beyond doubt that electrification is the way to achieve that goal.
And before we talk more into electric vehicles, hybrids, what's your take on it? Is it a good in-between step before we move towards full electric mobility, or are we already past that stage?
So let's look at it this way. Electrification of some sort or the other has always existed on automobiles.
Yep.
And therefore, there is always this incremental approach that one would take. And the benefits at that point are fairly lucrative. However, if the ultimate solution is going to be in terms of BEVs or battery electric vehicles, as we call them, and you have the opportunity to make a switch to the final ultimate solution, would you want to go through the steps or would you want to make an ultimate leap? Now, if you're able to do that, nothing like it. But sometimes these solutions, these intermediary solutions, could also be a way of approaching a certain end goal. So I would think that if we can be focused on the final solution, then that's the way to be.
Yeah, don't do half measures.
Don't do half measures. I mean, sometimes you will have some tactical gains out of it, but strategically and from a long-term perspective, if you've achieved something and you've decoded the way to get there, then focus on that.
Okay, so decoded, that's a great word. How did Tata Motors decode this whole electric mobility business? Now, you talked about the Vista Electric that was done as a demonstrator, as prototypes. You obviously got a lot of data from it. I believe you had also acquired a Norwegian company that gave you technology back then. So you had that technology learning. From there, okay, you have your main Indian rival also who acquired technology. So it's not like others were not acquiring technology or were not building up the knowledge bank in terms of electric vehicles. How did Tata Motors actually start off in terms of mass market electric mobility?
So you referred to the battery company.
Yes.
So we had a stake in a company called Milio, which was a Norwegian company. And remember that this is 16, 17 years back. So battery technology itself was on a very sharp maturity curve or a rising curve. And therefore, it was still early days. But it did give us a lot of insights on how batteries work, how do they need to be configured inside a car, how does it need to come together in a battery pack. So all of that implicit knowledge came our way because of working on that demonstrator project. Now, what happens when you do this is you collect a lot of data that goes into your systems, that goes into your learnings as guidelines, as strategies, as algorithms, and that helps you subsequently. So our advanced engineering teams gained a lot of these insights, and that pool of knowledge became resident, which stayed with the company from that demonstration project. But then when it came to being able to actually do a project, I think the ESL contract that came up in 2017.
Yeah, that's the Indian government
That's
contract.
the Indian government contract. That was a step in the right direction. I think while we were always thinking about electrification, it provided that impetus. And I think us emerging as the L1 bidders on that tender and being asked to fulfill a certain number of cars for the Indian government set the entire motion in the right way is how it happened.
Yeah, so just to give some backgrounder for our viewers and listeners also, that was the Indian government contract, and the main, at least everybody thought that it was the E-Verito that would win that because the E-Verito was on the roads for much longer and Mahindra had acquired Reva and they had that technology, they had the electric vehicle technology, but winning that with the, I believe it was with the Tiago or the Tigor?
No, it was with the Tigor.
With the Tigor that you won that, would you say that was the main, or at least the first step towards you guys focusing strongly on electric vehicles?
So the background work was always there, Shirish. I mean, it just isn't that you can come up when a tender comes up and then you can offer something. I don't think it works that way. So you need to have a lot of information, knowledge, and as I said, a pool of data to be able to manage or to be able to come out with these kind of products. So that was always there. The ESL did act as a trigger in the right direction, and we were able to quickly assemble a vehicle with the right kind of technology which met the requirements of the tender, and we were able to satisfy those requirements, and therefore beyond that it just worked well for us, and like I said, it provided the initial traction that we needed.
So from that initial tender to the Nexon EV, because let's face it, the Nexon EV is the flag bearer for Indian electric mobility. It's sold more than anything else put together. So how did that translate into the Nexon EV?
Along the same lines, at the time that we were doing the ESL, the aspirations had become larger, or they were already evolving, to say that how can we now bring electrification into the Indian space. And when you try and do that, you look at what are the problems that you want to solve. Now, we ran a project, a survey project internally, to understand what were the true difficulties that customers who would want to adopt electric vehicles would face. What were the barriers to electrification, in a way of speaking? So, when we looked at that, we found 4 or 5 very key aspects. The first one was that people did not have enough range. The second one was people always thought that electric cars are slow, they lack performance, and part of it is because you had a certain kind of vehicles in the market, and the references were always with respect to those products.
There were, obviously, because
And
that
there
was
were
the first, right?
there were products which had a certain purpose, but that's what was the impression. So the impression was that the performance would not be there. The third one was what would happen about the charging. Where would I charge? Is there a charging network good enough? The fourth one was what would happen to the most important component, the battery. When would it run down? And when it runs down, it is the most expensive part. So what would happen to my car? So there were these concerns. And the last one was India is such a diverse country. We have flash floods, we have heat, we have cold, and we have bad roads. Would the battery and the tech be durable enough to weather this out over a lifetime of the car? And that's what the 5 questions were. So we said that can we address this? And we went very systematically with saying that the solution that we would create would have to make sure that each of these questions were addressed. And when we came out with a solution to each one of these questions, what we have is the Ziptron platform. So the Ziptron addressed it because we said we would give a 160,000 kilometers or 8 years warranty, whichever was earlier. We would then make sure that these batteries sustained all the rigors of the Indian road conditions. Therefore, an IP67 battery got designed. We said that using Tata Power, we would create a network of charging stations, which would give all our users a hassle-free charging experience. We would also make it high performance. So the permanent magnet motors came in, and we said electric vehicles, in fact, everywhere else, they're talked about as performance cars. Unfortunately, in India, they were talked about as slow cars. So we said we'll erase that. And we said, what's a decent enough range for people who operate in Indian cities? And if you can do a 200-kilometer real life range, then it's good enough for roughly about 3 to 4 days of driving for most people.
Yeah.
And if you have these combinations come through, then you have a killer package. And that's what the Nexon Prime did. We called it the Prime later, but that's what the Nexon EV did at the time that it came into the market.
And this was a big step up from the earlier versions that you did for the ESL contract, right? Or was it already
the
there?
ESL? So the ESL vehicle was a Tigor, and it was a low voltage architecture. The Nexon EV was a high voltage architecture, and therefore, yes, significantly different.
Yeah. So these were the challenges that you saw in terms of adoption from the Indian customer. Range is still a huge issue with the Indian customer. Charging infrastructure is still a huge issue. I don't believe that should be as much as an issue as it is, but everybody still talks about range and the charging infrastructure. With the charging, the great move that you did with Tata Power was establish a network of chargers, and that provided the baseline for all the new age players to come in and then build upon. Where does that go now? You are now partnering with the fuel pumps to set up chargers all over. How long before you think the whole issue about charging infrastructure gets solved in India?
So let's look at this problem from 2 perspectives. When we did a car that was 100 kilometers range, people wanted 200. When we did 200, people wanted 300. Then a 300 comes along and people want 500. If the electric vehicle was earlier being looked at only as a city kind of a mobility, today it is being looked at as a all-place mobility, and it's possible for us to do that. And therefore, I see this challenge as a very positive one, that we have to solve this thing. So this is one part. The second part is we need to make the charging infrastructure significantly better, and can it become as ubiquitous as a fuel pump? And the answer is it can get there. It might need a little time. So apart from Tata Power, we've also tied up with a number of other charge point operators in an open collaboration. So Balaji Rajan, our Chief Strategy Officer, drives that initiative. And we are teaming up with a lot of these charge point operators as well as some fuel pump station companies to set up more charging infra. I would say, at least on the major corridors of the country today, you have no problems with charging. There could be some issues where you might come to a charging point and you might find that there is another car which is charging, but you will not go to a point where, oh my God, what do? I don't have a charging point. That's no longer the situation. Do we need to go further? Answer is yes. Can we do better? We are trying to always do that. So no doubt about it.
So with the Nexon, how difficult was it taking out the ICE powertrain and putting in an EV architecture? Is it all that difficult that all other manufacturers are making it out to be? How did you crack that so quickly?
I don't think it is very difficult. So converting a ICE platform into a electric enabled platform is actually relatively easy. What is difficult is to make sure that you do the optimum balance of the battery and the optimum balance of the chassis, because it's not necessarily the most ideal approach that you will take if you were to do a ground up EV.
Okay.
Because what happens when you do a conversion program is that you tend to spread the batteries around the floor, whereas the battery should be designed for itself. To a customer, it does not make a difference. But from a design perspective, from an integration perspective, you could have more optimal or more optimizable solutions available. It's possible to do it. There were other things that you need to look at is because of the mass of the battery. The weight of the car goes up, and therefore you have to also deal with crash safety and things of that sort. So you have to strengthen in some areas. That's the approach which we took in case of Nexon, and it turned out to be a very successful one.
How long did it take you to do that?
Well, traditional methods at that point of time were indicating time closer to 2 years. I think we were pushed really hard. And we pushed ourselves equally hard to deliver it in 15 and a half, 16 months.
And how did you do that? How did you accelerate your...
So we almost ran on a parallel path, Shirish.
Okay.
Parallel path meaning in any program, you have to have design of the components. You have to have those components getting into some level of physical prototyping. Then those prototypes are required for solving some other problems on manufacturing lines or setting up manufacturing equipment and seeing whether everything works or not. At the same time, you want to take feedback from downstream agencies like service to make sure that when the car and the component gets into the field, it has the necessary degree of support and necessary degree of capability to be able to handle everything. We ran most of these processes in parallel. So everybody got engaged on day one. And we prepared SEBA block batteries when a physical battery was not available.
What is a SEBA block battery?
A SEBA block is a material. It's a hard material. It's harder than thermocol, for example, but it is easily machinable. And so we prepared batteries out of that. And much before our first physical battery was in our hands, we'd already carried out actual trials of how the battery would get stuffed into the car, how it would get serviced, how it would come out, what kind of tools would we need, what kind of equipment would be required. All of those things were already done even before the first battery landed.
Were you surprised by the response to the Nexon EV at the start?
Honestly, yes.
What were you expecting?
No, so it was, in a way of speaking, it was a phase of discovery. We wanted the car to be successful. Everybody wants it that way. We thought that we had made the car very, very likable. And if you remember, on the day that you drove, or you all drove the car for the first time, you were genuinely taken aback by the feedback and the response that the car provided. So we had set it up that way. But how much would it be accepted was something that we needed to look at. And I think therefore at a certain point of time we were already selling more than what the I mean, we had sold in the previous year, for
Yes.
example,
Yeah.
all put together.
Yeah.
And that was a very nice.
Yeah, in fact, what we said when we first drove it was that Tata Motors' weakness was always the engines, not the diesel so much, but the petrol engines never really had that dum, that punch that we wanted. And the e-powertrain, that solved everything. That gave you performance and easy, usable
Gave
performance.
performance, refinement. NVH was all gone.
Automatic gearbox.
Yeah,
Right, you don't need a
everything.
gearbox. Everything is so it's easier to drive, more convenient all across. So
True,
all
true.
that was there. Now the next step on the Nexon, the Prime as you call it, how did that come about?
So what happened is in the first few days of the Nexon EV being released, and as it was released into the market, COVID struck. Within 15-20 days, a lot of people, I mean, we stopped dispatches of cars. People couldn't use the cars because there was no way of getting out and so on and so forth. But beyond that, uh, we started getting feedback, constructive feedback. And when you have an electric vehicle of that power, that capability, and that setup, sometimes it takes time to get used to regeneration, to the braking effectiveness, and to the power itself. And people are not used to do that. People haven't seen anything of that sort. So we started getting a lot of feedback, and we took that feedback very constructively. And one of the things that we saw, there was within a certain reason, that it made sometimes the car made people feel very naive drivers. The
In
response
terms
was
of
so the
okay.
response was so good. So for example, in a crowded city like Bombay, you push the throttle and the car surges ahead, and then you have to pull it back, and then the regeneration kicks in at a certain rate, then you have to brake. So
Made it like a very jerky driver.
yeah, so it made you feel like a novice,
Mm.
which is not correct. So we tweaked some amount of regeneration. Along with the same thing, we also realized that there were aspects of air conditioning performance. There were aspects of certain strategies, cooling strategies, for example. The cells were running very cool at that time. So we saw improvements possible. We also saw that cruise control was something which was liked by people. And by that time, we had already started working on the Max, and therefore we knew how to resolve that. Provided the hardware was there, we could have still given it as a software update to people. And therefore we said, why don't we club all of this thing together and offer it to people as a free upgrade? And that's what became the Nexon EV Prime.
Yeah. And then obviously now you have over the air updates. So the technology has also been
Correct.
rapidly expanding. What was the feedback? I wouldn't say negative feedback from your customers, but what feedback did you get that you then put back into your vehicles at the start?
It's always a lot of feedback that comes through. I told you about regeneration, for example. That's made us change our strategies. The thermal management, that's made us change some of our algorithms. Also, for example, the cruise control. People
You
wanted
mentioned that.
cruise control, and using cruise control, there are people who have reported that they've been able to improve the range on the car. They've been able to make it more smoother. It's a more convenient drive, so that helps. But at the same time, you're tracking long-term data. Long-term data could be for charging. It could be for components like what is the long-term cell temperature that it is operating at. And then you get to these levels and say, well, if my cells are always operating at this temperature, no matter what the external temperature is there a room for optimization? Because at the end of the day, it's all energy that you are carrying on board. Could you optimize this energy consumption to sort of give away something more for range improvement? And that's what we did with the
With
new
the
Nexon.
facelift. Yeah.
Yes, with the new Nexon. And I told you
Yep.
when we met for the launch
Yeah.
that this is how we were able to unlock things.
Yeah, so with the Nexon facelift, you didn't change the battery pack, you didn't add any more cells, but you did manage to release
Correct.
some more range, and that was basis what data that you got.
Correct. And very often you need to have this as a confirmed trend and absolutely correct data to be able to make a change. And that's why, while doing it is simpler, deciding to do it needs a lot of conviction and needs a lot of data.
So we've been talking about your conversion platforms. And now you have your pure EVs. The
The
first
active.
was the Punch,
Yes.
the active Acti EV, as you call it. Uh, with the Punch EV that we recently drove, you've sort of stayed similar in terms of the styling with the facelift, but the underbody is the
Completely
platform is
different.
completely new.
Yes.
Why didn't you go for a new look altogether?
So a lot of our customers are actually very comfortable with a familiarity of a known body style. The Punch has been an exceptional car. I mean, today for 2 months running, it is the largest selling car in the Indian market, and therefore it has a certain level of acceptance. It has a certain level of love that customers have about the product. What we therefore did was to maintain that love or to keep that association strong, but to also make a electric connection with that or a EV connection with that. So if you see, the bumper is different, the front
Yeah.
bumper is different, the the lighting elements are different, the charge port is now on the front. So these are aspects which stand out for the car. This is what the differentiation happens, and I think this combination of a known body style and a known silhouette, along with a completely different driving experience because of the electric, is something that it's like a sweet spot.
Yeah. Why didn't you do a simple conversion for the Punch, and why did you go through all the effort of a new platform?
So I had told you that there would be ways to optimize it further, and if you want to do longer range cars, if you want to do battery agnostic or chemistry agnostic battery packs, if you want to do more drive configurations, if you want to liberate areas like the frunk, for example, then you need to look at it differently. All of this is not possible with the same level of optimization on a conversion platform, and it's not necessarily the most efficient. So for example, when we did the active, and the Punch is the first one, we were able to save weight on the platform by about 15 kilograms. That means less material unnecessary. We were able to reduce parts complexity by about 10 to 12%. We were able to improve the torsional stiffness of the car by almost 30%. And that's what makes you get into a higher level of optimization. And you've driven the car. While the vertical impact is very cushioning, doesn't feel hard, yet in turns, the car is rock solid.
Yes.
So how do you achieve this balance? You do that because you've changed the platform.
Something that you have shown as a concept, but we still haven't seen on the road, is the Altroz EV. Why are you looking at the SUVs and not so much the regular cars? Obviously, you have the cars, which is now mainly a fleet vehicle, but otherwise for regular customers, for the average Joe, why are you not looking at a car in terms of an EV?
I don't think it's we are not looking at it. We have already said that there will be a lineup of 10 cars that we do between 2020 to 2025, 26. 4 out of them have already been released. We should shortly be going into a couple of more programs, and the Altroz has its sequence, but and therefore it's certainly not something that has been pushed behind, but it has had its own sequence, and we are working to that sequence.
Yeah. So now from Gen 1, Gen 2, you also have announced plans for Gen 3 and further on. You have the Harrier EV that's coming up, and you have the Sierra EV that's coming up, which everybody is very excited about. And then going forward from there, the Avinya. Let's talk about the Harrier EV. What are the challenges in doing something like that?
The challenges in doing something like that is, one thing is you need to find the battery of the right size. It's a large vehicle. When you can't allow it to be underperforming. When you make it a performing car, you obviously are talking about speeds that you can do, and aerodynamics is an enemy in this case.
In such a big vehicle.
In such a big vehicle, aero losses can be humongous. So in order to match all these things, you need to have a battery and a propulsion plant that can go in line with the expectation, and yet you need to make sure that the chassis performance is tuned well. So managing these expectations managing these requirements is the challenge. To be able to find the right size of the battery for the right motor, right kind of drive, and then when you do all these things, you need to equip the car with good features. So that's where it all gets into.
A car like this, a Harrier EV, the real world range, at least the target would be 500 kilometers.
Well, we've said the Harrier EV is on Gen 2, and we've always said that our Gen 2 products would be of a certain classification or a certain minimum range. And the number that you speak about is very close to that.
Okay, so that's in the ballpark.
I can't even say yes or no right now because we haven't got any certification done or yet, but it's still in the stages of development.
And of course, you're looking at all-wheel drive for the Harrier EV.
Yes, that is for sure that we will have drive configurations. All-wheel drive becomes a very potent combination.
And then from there, you have the Sierra EV that's coming up. That was one of the showstoppers at the Auto Expo.
Auto Expo, yes. So
what can you tell us about it?
If you go back 25, 30 years back in time, our younger days, the Sierra was one of the most iconic and
most desirable
vehicle for the sheer expression of freedom and for the sheer amount of imagination that it provided. Yeah, I think a lot of people recall that vehicle in the same way that we do.
We all have a soft corner for the Sierra. The name and especially the design, which has cues of the original Sierra.
Correct. So this was the intent, to bring back iconic car, an iconic nameplate, and could we therefore make sure that the elements of that car, which gave this immense feeling of freedom and gave drive to your imagination, could it be recreated in a modern avatar? So that is what the brief was to Martin Ullrich, our chief design officer, and his team. And I think they've come out with this brilliant design, which keeps the modern look, the modern expectation, but at the same time it is anchored firmly in that image of freedom, expression, imagination of the first Sierra. So I think it's and then you have the ability to do an electric propulsion, and you really unleash a car that is going to be a fantastic one to drive.
Yeah, so I'm not going to ask you when you're going to launch it because obviously you can't tell me.
And I'm not going to say that.
Yeah,
yes.
so but I want to ask you that now the Sierra is a new car. It's not like a Nexon that you got and then you reworked on it. Same with the Punch. Do you work in parallel with your engineers from the combustion engine side while developing a new platform? And how closely do you work with? Because now your Tata Passenger Electric Mobility is a different company altogether.
So because the teams came from an erstwhile single team, of course there is a lot of connections, there's a lot of network and a lot of discussion that keeps going on, and that is in fact aspect of our strength, so that we can have something to look at. But there's a lot of back and forth work that happens, because on cars where you have a multi-energy strategy, meaning, for example, if you look at a Punch today, a Punch is in an electric avatar. Of course, it has a separate platform, but the Punch is also in a ICE avatar. So there is a lot of discussion that keeps happening, and the references are always back and forth. But there is also a body of very specific, bespoke, independent parts, particularly on the propulsion side, where you don't need to be challenged, or you don't need to be constrained by what you would do on the ICE side, and you can therefore chart your own expectations, or the design can be led in a certain way, the engineering can be led in a certain way. So we use the best of both.
But there must be some areas that you would want different, but you can't do anything about it because you also have to have a combustion engine there. For instance, with the Curve, now the Curve is coming up in both ICE and EV avatars. Are there any frustration points for you?
This was, I would say, more when we were doing pure conversion programs. As we have started to chart out a slightly, it's come to a fork. We talked about that. We've come to a fork where now the EV team, uh, right from day one, decides on what is optimal, what is ideal for its approach, and therefore those points of frustration, as you said, have significantly reduced because you don't have those compromises, you don't have those confrontations. But yes, there will always be points where there will be a commonality, and when you have this commonality, the best way is to solve it in a way that benefits both teams. So that's a discussion that does happen. I don't think we've come to a point yet where we say it's an absolute no-go for one program if the other program has it. We have been very successful at finding solutions to both sides.
Yeah. And then obviously you have the Avinya, which will come after all of these other programs come to fruition. And that looks like something that would be a pure EV because in terms of the packaging, in terms of the styling, everything is totally radical. Do you think India and your Indian customer is ready for something like that?
Let's look at, so before I say yes or no to that, let's look at what does a bespoke EV platform provide you. It liberates a lot of space which can be used by the occupant,
especially between the wheels, right?
Especially between the wheels. It therefore gives you a lot of opportunity to do radical design themes, which is what the Avinya is, by the way. It also gives you the ability to completely liberate yourself from some of the other constraints that you would have had in terms of utilization of space in the back or utilization of space in the front and drive configurations, etc., that we have already spoken about. So it is an unconstrained evolution of electric car. And why wouldn't an Indian customer like it? Because if that's what he or she is going to see as something coming from some other competitor, then here's a product that is grown completely within the country, developed for the country. It is no less in any aspect as compared to a global international product, and therefore I think it has a lot of appeal and it would be loved by a lot of people.
And I want to pick on that because over the past, especially COVID and post-COVID, there's a lot of love for Indian manufacturers. And Indian manufacturers have been churning out products that are capable of attracting that kind of love.
Yes.
Y'all make 5-star rated cars, very safe vehicles. In terms of design, y'all are right up there. In terms of value for money, you've always been right up there. So today there is, in fact, forget resistance. Today there's a lot of love for Indian brands and a lot of acceptance. So I don't think that, and I was not referring to that in terms of acceptance. I was talking in terms of the unconventional shape. For instance, Indians have never liked estates, but you can't really pigeonhole it into that this is this body shape, right?
So it is like a SUV-ish profile, but it is not an SUV. It is not a sedan, and that is the disruption that I referred to. So when you have see, at the end of the day, any disruptive design, if it is capable of meeting customers' real life use cases and is not hindered, the use cases are not hindered, then there is a better acceptance of a disruptive design. And the way that the car is getting designed or is designed today is you will not have any disruptions. In the sense of hindrances. You will not have any hindrance, and therefore there is no reason why the acceptance wouldn't be there. Of course, having said that, we do whatever we can to make sure that designs can be tweaked and this thing through surveys, through customer groups, and through feedback loops that come through. And all of those processes are anyway going on currently. And therefore what you will see eventually is something that is very, very unique.
Yeah, I'm looking forward to that. I want to change track and talk about career opportunities.
Okay.
Now, when you started off as an engineer, there probably were like 5 verticals that you could find a job in. Today, in your electric vehicle business, what are the opportunities for engineers? What do you look for when you hire new engineers?
You reminded me. when I passed out,
Mm.
there was mechanical, civil, electrical,
Mm.
and probably instrumentation was
Mm.
coming around.
Mm.
But today, and of course, electronics was there. But today, what we are doing is something like mechatronics, which is a fusion of so many things. People are doing robotics. When we look at uh, what do we look at people? I think uh, fundamentally engineering capabilities have to be there, but more importantly, it is the ability to solve problems. And ability to solve problems looking at multiple areas, not just area of your own. I think these kind of capabilities go on to become very, very successful. I would also think that it is no longer useful for people to be an expert only in one specific area. People should actually, we are a product industry.
Mm.
The product industry has to be lived with. You cannot stay away from a product. Therefore, you need to be able to drive the car. You need to be able to find out how the car is behaving, because behind all of this, finally you have to get the four wheels on the road, and it has to behave in the way that it is expected to behave. So I think all of this is what we look at people. Uh, we need to find people with the right sense of understanding of the vehicle itself to begin with, and then about how technology can be used to harness that. I think that becomes a very good combination.
Do you look at certain educational background, and what do you look at?
So we look at our people join us at different levels,
Mm.
and because uh, there is a multitude of functions, right? And not every function needs the same level of qualification. So we have diploma holders coming to us. Of course, a large majority of our people are either graduates or postgraduates, and then we also hire some PhDs to do work in very specific core areas. And then, of course, if you look at in strategy, or if you look at in the planning function, we have people who've walked out of MBA colleges, management schools, things of that sort.
So you said that when people have, like, when manufacturers, when they have newer technologies, it's not like anybody teaches anybody else, and it's not like people share information with other competition, right? So how do you acquire leading edge, cutting edge technologies?
So while it is true that you wouldn't really share, I mean, we are very, as an industry, we are very closely guarded about what we do, and you can't avoid that, because a small piece of information could mean a competitive differentiation edge that either goes away or gets retained, whichever way you look at it. But there are ways and means to do it. In terms of, technology always follows a certain trend, a certain growth path, and therefore, if you are careful about it, at least in at least in many aspects, if you know what has happened in the past, you can predict at what pace technology will grow in the future. If you looked at in 2010, the screen size on cars was 4 inches, 3 inches, and we fought about that. And yet at that time, you had smartphones which were coming, and smartphones were growing in size. So it was possible to make a connect to say that in a few years' time, you would need to have screens in the car which would be significantly larger. And then, if people called out on those aspects correctly, they wouldn't be surprised. And that's how things work. So good companies always invest in this kind of trend mapping, trend spotting, and correcting their plans according to that. Then there is a lot of benchmarking information that comes in, etc., etc. So from a long-term future, it's always about mega trends. Then it follows trends. Then it follows to more tactical interventions. So you look at all these things.
What are the mega trends in the EV space? Now, people have been talking, especially the Japanese, have been talking for very long about solid state batteries. How far away are solid state batteries according to you?
Well, solid state battery is the utopia.
Mm.
It's always been that way, but I started working very closely in the electric field about 6.5 years back. It's always been 2 years away. So I think a lot of work and development is still going on. We should be getting to that, but there are some few fundamental issues that still need to be resolved. One of them is, how do you do them at scale? How do you manufacture them at scale, etc.? I still think it's some time away It's been known how to do that, but we've not had anybody crack the problem in a very commercial and in a scaled way. It will still require some time, is how I would guess it.
So where we are right now, what is the next step in terms of battery technology?
So the battery chemistry technology per se is evolving, let us say gradually. It is evolving in a way of a linear trend. So the densities are growing at a certain pace. What is changing very quickly is how people package those batteries inside a car, and therefore you have technologies like, or not technologies, but approaches like cell to pack and cell to chassis, where you are essentially trying to remove all the voids in a battery pack and pack as much dense batteries as possible, so that under the same footprint you can do a larger battery pack, you can do a more capacity. That's what is happening. People are also working with a choice of materials between steel, aluminum, composites, and those kind of stuff, to see what is the most optimal weight distribution that can be generated, and how do you manage the batteries for safety as well as for cost. That I think is how the industry is looking at it today.
Uh, is it true that in the EV space, it is easier to incorporate newer technologies rather than in the combustion engine space?
I would qualify that statement as depends,
Okay.
because there is certainly a lesser challenge if we were to incorporate certain things, but it all depends on what component you are talking about. For example, if it is battery construction, you could easily do that, but then it would mean, for example, that you would need to go to a completely different cell, and that may not be as easy as doing it. It is possible, but then it comes into a more commercial discussion, or a discussion about commitments that have been made, etc. Power electronics is an area where a lot of work is being done for very small gains, but a lot of work is done because people are trying to extract the maximum out of that. Now, therefore, if you look at what kind of chips you're using, then it may not be possible to emulate something which has been done by somebody else very easily, because it may need a change in that electronic architecture. So sometimes it is easy, sometimes it is not.
Okay. Looking forward, you have this partnership with Jaguar, where you will also be exchanging technologies in the electric vehicle space. So, what are the plans?
So the idea is that we've taken the EMA platform. The EMA platform is a global platform. It's a born electric platform, and it can spawn a large number of vehicles. JLR's vehicles, of course, they've done it for their vehicles, but it will be possible for us to integrate and design our vehicles around it. The Avinya is going to be built. The Avinya is the first product to be built on that platform from the Tata Motors side. And there could be more products on that same platform, because it's a capable platform, it's a flexible platform. Now, this will also mean that there's a lot of synergy, which could go beyond just sharing the platform. It could also mean sharing of platform parts. It could be propulsion, it could be battery cells,
Like common motors, for instance.
common motors, for example, or it could be common architectures. It could be things on the E&D architecture. So there will be a lot of, because all of that has to be mated to the base architecture, and that's what has already been done on the IMA, because it is the electrical modular architecture, and that's how the synergies will come through.
How far away is India from self-sufficiency in the electric mobility space?
When you say self-sufficiency,
we don't have right now capability to build the cells in India? Is that coming up? Do you see
so
that coming
there are
on the horizon?
people in India who are actually doing cells, but they're not doing it at scale. And there are companies in Hyderabad, there are companies in Bangalore, but they are doing it on a very small scale, but they are doing cells. So in that sense, the understanding about what goes into cell making is there. The question that I think you are asking is, when will we be able to make cells at scale? And I think we have a lot of interest from multiple companies today uh, who are wanting to do this. Tata Group company Agratas is also wanting to make cells in India. They have plans. Of course, I'm not at the liberty to talk about that today, but therefore, earlier than never, you will see cells being made out of India.
And we are also talking about finding lithium reserves in the country. That's a long range plan or that you see coming up.
Let me say, whatever vehicle we have electrified, we have electrified 4 vehicles. Whatever vehicle we have electrified, we have immediately gone to a penetration level of between 20 and 25%. Okay. Does this mean, therefore, that as more options become available, people have more choices and the penetration could be about 20-25%? That is one way to look at it. If the answer to that is positive, then I would also say that given the improvements that are happening to cell technology, to propulsion technologies, and the prices of cells coming down, etc., you could also get into solving another concern that is there in the people's mind, which is about usable range for a certain accessible price or access price. And if that gets solved, there is no reason why the percentages cannot go up from here. So you need 2 things to happen. One is you need more choices. The second one is you need parity to come in. Now, look at it this way. When we launched the Nexon EV, the premium on the car was at 35%. That was for a 200 kilometers range car. Everybody said, when do you get to parity? Today on a 200 kilometer car, you are probably at parity, but people want more. The 300 kilometer car is more expensive. The 300 kilometer car could also go to parity soon. I don't know, in a few quarters time. We'll have to see. Will people ask for a 500 kilometer car? So where does the parity point get locked in? If it is around 350, 400 kilometers, you achieve parity, there is no saying how much the penetration will shoot up by. Awesome. And that's what has happened in China as well, which is the largest market. You achieve that parity and the 350, 400 kilometer mark is where the thing really picks up.
So that is the inflection point from where things really start to rocket.
Yes.
Awesome. Thank you, Anand. Thank you for spending time with us and really running us through like a detailed look at electric vehicles, especially in the Indian perspective. One last word on e-mobility in India.
Well, I think it's a course that has already been set, and we continue to work on it because we believe in it. The market continues to trust and expect more of us. This will gain pace as we go on in the future, and therefore I don't see this as a reversal happening anytime. This is going to go forward. It's just a question of time.
Awesome. Thank you, Anand.
Thank you. It's been a pleasure, Shirish.
Thank you, Anand.
Thank you very much.